Hi everybody, welcome back to Kosmos. So in today's little video I want to show you an adaptation or an improvement to my little lathe center height gauge that I made a couple of years ago, well a few years ago now. So this design was originally published in England in Model Engineers magazine, and then later in the author's own book. And the author was a man called George Thomas, so quite well known in model engineering circles. And he designed a little lathe center height gauge for setting lathe cutting tools on the center line of the lathe. Now there are lots of quite easy ways of doing that, and lots of over elaborate ways of doing that also. This is a quite useful way because the tool doubles as a scribing block, and so you'll see that the tips are very sharp, and in fact these steel flats here are hardened, and so the tip can be used as a scriber. And you can also see that there's a little raised area there, which is just a kind of clearance zone, and so only the tip of this tool will be used to gauge the center height, and the same on the upper one. The reason there are two is so that one can use the tool firstly on the bed of the lathe, so this seated flat on the bed, in which case you would use the upper limb of the tool as your center height gauge, or you could put it on the boring table or the cross slide, in which case the whole tool would be raised up somewhat, and then the lower tool or the lower indicator would become the reference surface. And so that's the reason that there are two there. Mine has a bit of a problem, in as much as I wasn't that careful when I soldered these pieces of steel into these bullet-shaped bodies here. And I think they soldered with, I seem to remember using low temperature silver bearing solder, so it's stronger, say, than lead solder, but melts at a much lower temperature than what we call silver solder. So I think this melts at, say, 250 something degrees centigrade. The flat surface that's visible there in my tool isn't horizontal or parallel to the bottom of the tool, which is problematic because it means really only the tip or one spot on this thing is actually reliable as a reference surface, and so that makes the tool unpredictable in use. I think the way I set it was against the center in the lathe, and so the very tip is in fact lined up with the lathe center, but nothing else is. So what I'm going to do today is just put a very small grindstone in the chuck of the lathe, or perhaps in a collet, and grind the tool on the lathe itself. And so what I will get is an absolutely flat undersurface to this little pointer, and so that it could be used more reliably as a lathe height setting gauge. So I've got a lathe cutting tool here. This is my diamond tangential cutting tool from the Australian Eccentric Engineering. And so anyway, you can imagine this mounted in the tool post of the lathe, and you'd want to set the height of this before you start work. And so you'd raise this until it touched the underside of that flat there, and then you'd know that this tool is on center height. So that's why that surface would need to be absolutely parallel to the base. Otherwise your height setting would change depending on how far in you happen to register the tip. And so that's what I'm going to do today, is grind this undersurface. While I've got the tool out, I'll show you a few details of its construction. As I said, the design itself was that of George Thomas, but George Thomas had a relationship with a company called Hemingway, who produce kits, and they have castings for such projects that need castings, and so they supply kits for making internal combustion engines, model steam engines, and also lots of workshop tooling and equipment. And so this was one of their kits, although it's not really a kit, it's just a box of stock material of appropriate sizes that would be suitable for making this. And then of course they've got very good drawings that one could follow. So the Hemingway design differs slightly from George Thomas's original in as much as it's been simplified in some respects, and the base in this case is completely round, where I think George Thomas had it as a little, rectilinear block. And I think I could probably pull out the drawings somewhere in my studio here. I think they specified that part of this block should be milled away, just so that you get closer to something. But I didn't see the necessity to do that, because my lathe is bigger than a lot of model engineers' lathes would be. Anyway, I didn't see the necessity to mill 2/3 of this block away, or 1/3 of the block away. So the other thing is, I didn't make thumb screws. They specified brass thumb screws, but I got impatient towards the end and just used stock screws. So there are 1, 2, 3, 4 pieces here. So if I undo the screw, and so what you have is the upright. It's quite tight. So there's this piece which is knurled and threaded, screw cut, all in one operation. There's a necessity in this job to make sure that surfaces were truly square to each other, because it's in that squareness that some of the precision of the tool lies. And the reason for that is, if there's any out of upright error, say if this upright were tilted over slightly, it would mean that any reading as you spun the tool around would cause this tip to take up different positions. Anyway, things just work better when they're properly made, and so it was important that this staff is truly square to the undersurface. So there's a threaded section there. I just press this out. So that's cast iron, and there's a fine bore down there, which is a close fit in this little insert. I think in George Thomas's original design, this whole thing would have been turned out of one piece of steel, but I suppose the good people at Hemingway decided that that's quite a lot of turning to do between centers, and this was finished turned between centers to ensure truth. And so this was assembled, sort of fabricated, assembled, Loctited together, and then finished turned between centers. And so what we have is this piece which is threaded. This surface here is very important that it's really true and square, because it registers against that face. And so as the two components are pulled together by the thread, it's that mating, that pair of mating surfaces that guarantees the final uprightness of the whole thing. So I'm going to reassemble it. I'm going to use a touch of oil, of which I happen to have some just off camera, just to aid my disassembly at any time in the future. And also because I've been handling it, There's a good chance that any moisture from my fingertips would invite rust unseen later. So just a little bit of headstock oil on the assembly surfaces will go a long way. So I agree that this part looks quite simple and indeed should be straightforward, but if you do decide to make something like this, do be sure to get this undersurface absolutely square to the staff. So what I'm going to do is remount these just lightly to begin with, and then I'm going to grind them. I'm going to install the little grindstone in the lathe and grind these surfaces truly square to the base. This is the little grindstone I'm going to use. I won't be running it at a tremendously high speed. I mean, I'm just going to run the lathe at a fairly high speed, and just through those faces. Right, so of course I've immediately encountered problems, although they are quickly solved. I've got this set of 4-Morse taper Collets, lovely Chinese Collets, and upon opening the box, immediately recognized that there's no way that one of these Collets is going to hold the little grindstone. I thought they'd go down to small sizes. I've only used them once or twice. You can see only 2 are unwrapped. And in fact, I think this is an older European-made thing, whereas these others are the import specials. So, next option is the Myford Collets. However, Myford Collets do not fit my lathe, because my lathe is a 4-Morse taper and Myford Collets are made with a 2-Morse taper. But in any event, I have a way around that. Yes, as I thought. No. Oh, wait. No, these are metric. So those are the metric Collets. And I think this is a 1/8. So no matter how much tooling you have, there's always a chance that you don't have enough. That looks about right. Yes. Is it? Maybe? Yes. Okay. And in fact, this one's stamped 1/8. Okay, so we've got the collet. And I completely by coincidence one day when browsing around an old tool shop found this very interesting article, which is an insert for a Myford 254 lathe. Now mine's a 254, and it's a collet holder for the 254. Because as I said, the Myford collets are 2-Morse, and so this is basically a mandrel reducer expressly designed to convert a 254 into something resembling a classic Myford. And so you see the classic Myford spindle nose thread on the end here. And these Myford collets are inserted into the end of the spindle. But in order to get them in, I'll just clear some of this stuff away so I can put that down. We need to use, oh, is that the remover? I can never remember which way around this thing works. And that's a spare spindle nose cap. And so this is what compresses the collet. So this threaded cap kind of squashes the collet into the taper and closes it. And so you need to use this this tube. Let's try and remember which way around it goes. No, maybe. Basically, I think we just need to squash the collet down by pressing it into the tube. That'll allow us to slip the nose piece over the end of the collet, I think. I'll try this one. Doesn't seem to make much difference. Don't know which way around is tapered really, I can't see. That feels bigger, that feels smaller. So we'll put it in there, squidge it. Let's try again. Yes, that's it. And then we release it like that. So now the collet is captive in this nose piece and can then be inserted into the bore and nipped down. So you can see that as that black ring is threaded on, it will draw the collet closed right down into taper. So over to the lathe. This is installed down the manual of the lathe, and that's a kind of piece just to keep it captive. So here we are again at the Myford. I have poked my finger down that bore a few times. I think I should use Mr. Yellow Brush. I think I've referred to this in an earlier piece of footage which hasn't been published as a film yet. So it's a pretty neat spindle cleaning brush. Very important, especially when one is putting something like a tapered piece of tooling into the spindle. Just make sure that's really clean. You can feel with the sensitivity of your skin whether or not any chips are present. And this little tail piece is made to be a good close fit in the outboard end of the lathe spindle, so that the back end runs pretty truly. We have to open the lathe cover in order to access that part. So you can see that I need to adjust the height of these components. Right, so I've adjusted the height. I've dropped the lower tip and I've adjusted the upper one just to kind of clear the stone. I don't even know if it's going to make contact when I start the thing turning. But we've got to start somewhere, and there's no easy way to reset the height of this. It's not like a surface grinder, you know, where you've got a kind of hand wheel to feed the job. I'm going to find a pair of safety glasses. Oh, yes, there's a pair of safety glasses right on top of the machine where they should be. And so let's begin. The stone is really running out horribly. So what I've done is taken a boring bar holder. Well, it's not really a boring bar holder because it doesn't have a little V groove in the base, but I've taken a quick change tool holder and mounted a little diamond grindstone dressing tool in there. And of course, life's great ironies. I can't really set the dressing tool onto a precise center because I don't have the center tool because I'm trying to use the grindstone to fix the center tool. So it's always the way, isn't it? Although I think there is an argument against having the dresser on center. Technically, as far as I remember, it needs to be below center line in order to successfully not mess everything up. I think if you're doing surface grinding, if you're dressing a surface grindstone, then I think, I have to think about this, the diamond dresser needs to be on the trailing edge of the stone, so after the center line. So I will, so that there can be no chance of it digging in and sort of digging deeper and causing more damage as it does so. So I'll just drop this tool slightly below center, maybe a bit higher than that. And just eyeball it. Yeah, it's considerably below center now. Right, so here we go. In fact, I'm going to speed up the machine somewhat. So now I've got the machine on the second highest setting on the pulleys. Make sure it's all clear. So I've just readjusted my lathe belts. The belt was so slack, completely slipping on the pulleys, and now much better drive at the moment. I'm putting the belt onto the fastest pulley, or the fastest setting in the drive. I don't think I've ever run it at this speed before. So in this first session, I was bearing against a piece of paper, just to give me an easy way of dropping the whole job by a small distance later in the game, which I'm going to do now. So I'm going to remove this little sheet of paper. There is some grinding dust gathered around, which I'll be very careful to clean off after the job's done. And if you look carefully, you'll see that actually the entire front section has been ground away. Such was the inaccuracy of my initial soldering job. So now I'm going to try and finish grind this first little nib. So it's a pretty rough surface, as you can see there. Lots of grooves, lots of striations in the work. So I'm just going to work over it for a little while until those little grooves disappear. So here we have a much better surface than seen before. Although it's a bit grooved, it looks worse on camera than it does in real life. But we do have a truly flat undersurface, and most importantly one that is parallel to the base, thereby rendering the tool completely useful. It's hard to tell how much of that grinding action was the grindstone being chipped away, because there's a fair amount of pink dust over everything now, although not as much obviously as when I did the truing up with a diamond. But this type of stone and the speed I'm running at combined, it's just not enough to create sparks, and so it's actually quite hard to gauge what's really happening. But I could see metal being cut, and the results of the operation are, self-evident. That metal has been ground away in the orientation which I intended. So a simple process now of stoning away what small burrs exist, and I'm literally using a piece of just a half a broken Arkansas stone. I don't want to touch the tip because, as I mentioned earlier, the tip is actually a scribing surface, and that's been hardened. I might just run the stone off the edge because there seems to be a little wire edge or rag there. That's it, nice and smooth, with a nice sharp scribing surface. They're not absolutely square, but it doesn't really matter because you just, attack it with whichever part is closest and sharpest.